Shoot. Alright, well there's Ricky.
Let's have a stand.
And then introducing Justin. Hey, alright, there's me. Hello.
You're ugly.
Okay.
That sits inside your throat. Change the locks, change the scene, change it all, but can't change what we've been. Your troubles in my head. Your troubles in my head.
The graph of g of x is equal to negative 4 to the absolute value of x plus 2. Is a reflection of the x-axis, vertical stretch by a factor of 4, and a translation 2 units down in the graph of the parent function. Choose the correct order for the transformations of the graph of g. Explain your reasoning. So we have we have our equation, which is g of x is equal to negative 4, and so on. So the order of the transformation is a vertical stretch by a factor of 4. Followed by a vertical translation 2 units down. Since the regular equation has plus 2, you're always going to do the opposite sign. And then there's also a reflection in the x-axis. And yeah, that's pretty much it. A jumping bobblehead Ricky hops along a parabolic path given by y is equal to negative 0.2x plus 1.3x, where x is Ricky's horizontal distance traveled in feet, and y is the corresponding height in feet. Can Ricky jump over a fence that is 3 feet high? Justify your answer. To be honest, he can't. He has no hops. To determine if Ricky can jump over a 3-foot high fence, determine the maximum value of the parabola. Find the coordinates of the vertex, which would be, use the vertex formula, x is equal to negative b over 2a, which, if you were to plug in your numbers, which would equal to negative 1.3 over 2 times 0.2, which equals to 3.25. You then plug in your numbers to your equation to x. So y is equal to 0.2 times 3.25. 3.25 squared plus 1.3 times 3.25, which would equal 2.1125 feet. The highest Ricky can jump is 2 feet, and which is less than 3 feet. So Ricky cannot jump over. So to make it simple, Ricky has no hops.
I go. Hello there. For this problem today, Michael sells 330 tacos each day for each 25-cent decrease in price for $6 tacos. Michael sells about 15 more tacos. How much should Michael charge to maximize daily revenue? What is the maximum daily revenue? Define the variables. Let X represent the price increase and Rx be the daily revenue. Revenue. Write quadratic equation. Rx equals 330 plus 15x. 6 negative 0.25x. Okay, solve the equation. This equation. Divide both the parentheses, then find average. Negative 22 plus 24 over 2 equal 1. To maximize the revenue, each taco should cost $6 minus 0.25, which would equal $5.75. To find maximum daily revenue, R1 equals 330 plus 15 times 1. Then 6 minus 0.25 times 1 is 345 times 5.75. So your max daily revenue would be 1,983 and 75 cents.
Total attendance, A, in thousands, at Michael's basketball game, and the number, T, of Michael's basketball teams over a period of time can be modeled by, I'm cramping. Wait. By A, the number of people, which would be negative 1.9x cubed plus 70.1x squared minus 188x plus 2,150 divided by the teams, 14.8x plus 725, which would be 0 is less than x is less than 18. Thank you. Good night.
Mr. Suhu, I need you to get cozied up real quick.
Ooh.
Because this is going to take a long ride.
Oh, long ride.
Michael and Justin are playing a number guessing game. Michael asked Justin to think of a positive number. Square the number, multiply the result by 2, and then add 3. Justin's final answer is 53. So you use the R equals 2n squared plus 3. Then n equals the square root of r minus 3 over 2. So what you get is n equals square root of 53 minus 3
I like that.
over 2. And you know what you get?
What?
You get equal 5.
I like that.
Boom, there's your answer. Hello. Good morning, Mr. Suhu. For this problem, Michael makes a rectangular quilt that is 5 feet by 4 feet. He used the remaining 10 square feet of fabric to add a border of uniform width to the quilt. What is the width of the border? So 4 plus 2x and 5 plus 2x, as you can see. And you use the FOIL method. And when you use the FOIL method, you use the combine like terms. And then what else? Then you get 1/2, and then there you go. There's your answer. Boom. Good night, Mr. Zuhu. Is my hair okay?
Yeah, you're fine. You can kind of keep going.